In the last video, we looked at both the average cost and the marginal cost. Now is the time to bring them all together and see the relationship between them. If we draw our marginal cost curve is U-shaped, and let's draw that to see how the relationship with average cost look like. We saw for the first two workers or quantity of 90 in our spotless car wash, our marginal cost was going down, and then our marginal cost starts to increase as we saw more and more workers were hired. This happens primarily because of, again, the law of diminishing return. If you remember, for the first two workers, our marginal product was going up. So for the first two workers on 90 units of output, when the marginal product was going up, our marginal cost is going down. While marginal cost starts to rise beyond 90 units of output, and we can attribute this to our increasing MP for the first 90 units, and then later on we will say there is diminishing MP. We can also look at it from the perspective that as your MP is rising, and I would like to draw here simultaneously my MP. For the first two workers, when MP was rising, you can see this marginal cost is going down, and then for after the two workers, MP starts to fall or marginal cost starts to rise. Now we can say this, that each worker hired is adding more to production than the worker before, when we are looking at marginal cost going down or MP going up. But that also means that fewer additional workers are needed to produce an additional unit of output because workers are very productive. Beyond the two workers, however, things become different, because then after the first two workers, MP starts to fall or diminishing marginal return sets in and MP falls, which also means MC starts to rise, marginal cost starts to rise, which means each additional unit of output costs more and more to produce because the worker productivity is going down. So as long as MP is falling, marginal cost must be rising, and vice versa. As long as MP is rising, MC is falling. So they have an inverse relationship between MP and MC. Now on this marginal cost, if I now plot my average cost, so my average fixed cost will of course declines. That's something which we may not need to plot here, but let's look at average variable cost. So our average variable cost looks something like this. It falls, but as soon as it meets MC, it starts to rise. On the other hand, ATC also falls, but it will be above AVC because ATC includes AFC, so it will be also a U-shaped curve, starts to fall, but as soon as it meets MC, it starts to rise again. But the gap between ATC and AVC will be shrinking. We did talk about why the gap between ATC and AVC is shrinking, and the reason primarily for that is that this gap here is basically my average fixed cost, and this average fixed cost is declining as quantity goes up, and that's why this gap is shrinking as we produce more and more. Now when we look at marginal cost, the marginal cost relationship seems to be such that when MC is below our ATC and AVC, both ATC and AVC are falling. Look at this, when the yellow line is below AVC, the blue line is going down. As soon as MC is above AVC, AVC starts to rise. And similarly, when MC is below ATC, ATC falls, but then ATC starts to rise. When marginal cost is below our average cost, we know that the cost of producing one more unit of output, which is your marginal cost, is less than the average cost of all units produced so far. So if your marginal cost is 20 while the average is simply 25, then clearly average will go down, because producing one more unit will bring this average down because margin is below the average. So when the marginal cost is below average cost will come down, and this applies both to the variable cost and the total cost. So when marginal is below average, the average goes down. When margin is above average, the average goes up. We can say this, that when you do better than the average goes up, and when you do worse than the average goes down. So when you do better than the average, let's say when margin is above average, you can pull up the average, and that's why averages are going up when the margin is above the average. When you do worse than the average, when margin is below the average, of course you bring down the average goes down. Interestingly, graphically, the AVC at each level of output is derived from the slope of a line drawn from the region to the point on the TVC curve corresponding to the particular level of output. What do I mean by this? If you look closely to this diagram, and let's say choose any point, let's say we choose a point like Q2, which is this quantity, and let's go and find Q2 here. So this is the total variable cost, and this is the quantity. So if I look at the value of average variable cost at Q2, what I need to do is that I can find out the TVC, which is this distance divided by your quantity, which is Q2, and therefore I can get myself my AVC at that point. So in short, that AVC at, let's say, each point, for example at point Q2, for quantity Q2, is simply a line drawn from the origin to the point on the TVC curve. So the slope of this, remember the slope, the formula for slope is also change in y over change in x. So change in y will be this distance, change in x will be this distance. So the slope of the line which is drawn from the origin towards the curve will give you the value of the AVC. And you can see that, and we can see also that the point where your TVC is minimum, this quantity Q2, is the flattest possible line which is coming from the origin then touching the TVC curve. In other words, here TVC, it's tangent to the TVC curve, and if I draw any more lines which are lower in slope or more flatter than this line, I will not have any line touching the TVC. So in order to find the lowest point of the AVC from the TVC curve, all we need to draw is a line from the origin all the way touching the TVC at the lowest possible point. Similarly, we can do the exercise for total cost. The slope of the line which is coming from the origin and touching total cost curve will give you the value of ATC, and the lowest point of ATC, where ATC is the minimum, will be the line that is the flattest line possible touching the total cost curve. So look at this quantity Q3, which is this one. At this quantity Q3 or point C, your ATC is minimum, primarily because this line that is coming from the origin and touching the total cost curve is the flattest possible line. So if somebody says what's the ATC at Q3, all I need to do is find out the vertical distance, which is my total cost, right, which is this point, my total cost curve, and then look at my my quantity, which is this Q3, and I'll get myself my ATC. So ATC simply is TC over Q. So we can say this information is pretty useful because I can, from this graph, figure out all my points where MC, TC and TVC is minimum. For example, point A is when the TC starts to rise at a faster rate, is when my marginal cost is minimum. Point B, where the slope that is drawn from the origin to TVC is the flattest, is the minimum, is the point where AVC is minimum. And similarly, a line that is drawn from origin to TVC, which is the flattest one, is the one where ATC will be minimum. And the flattest means that both B and C are forming a tangent to your TC and TVC.